Okay, this is the second half of the review for 5 solving rational equations. All right, so we're going to do first here is we are going to multiply. We have a fraction. We're trying to solve for x, so we want to get rid of the fractions when we're solving for x. So I'm going to multiply both sides by whatever's in the denominator. I'm going to multiply both sides by x plus 4. Right? If I multiply it on the left to get rid of the denominator, I need to multiply it on the right as well. Okay, so I get 1 equals, and then I distribute by 5. I get 5x plus 20. All right, and then from there, it's a two-step equation. I can subtract 20 on both sides. That gives me negative 19 equals 5x. I can divide both sides by 5. So I get negative 19 over 5 equals x. Okay, and that's the same as negative 3.8. So if you put it as a decimal, negative 3.8, that's fine as well. All right, the second one, same sort of thing. We're going to multiply both sides by x minus 3. All right, so we get 3 equals, distribute, you get 6x minus 18. Okay, and then it's a two-step equation. I'm going to add 18 to both sides. We get 21 equals 6x. And then I'm going to divide both sides by 6. I get 21 over 6. That's going to reduce to 7 over 2, or 3.5. Okay, 3.5. All right, the third one, we're going to multiply both sides by x minus 7. So we get 2x on the left. On the right, we distribute our 3, so we get 3x minus 21. From there, it's a two-step equation. I'm going to subtract 3x from both sides. I get negative x equals negative 21. And then I'm going to divide by negative 1 on both sides and get x equals positive 21. All right, so that's our first type of problem. Okay, so we're good. Second type of problem here. We have the same denominator, right? So if I multiply both sides, if I multiply everything by x minus 2, right, I'm going to cancel out both my denominators, right? And another way I could look at it is multiplying both sides by x minus 2, right? If I multiply one side by x minus 2, I can multiply the other as well. So they cancel, and I get 4 equals x squared. To get rid of a square, I take the square root. The inverse of a square is a square root. Okay, and then I get plus or minus 2 equals x, right? It could be the positive or negative version. So my two solutions here are x equals 2 and x equals negative 2. Okay, but if I look up, I have x minus 2 in my denominator. So if I substitute in a 2, 2 minus 2, right? 2 minus 2 is going to give me 0, right? X minus 2. So if I substitute in a 2, I get 2 minus 2 is 0. I can't have a 0 in the denominator. So 2 doesn't work. My only solution is x equals negative 2. If I plug in a negative 2, if I substitute in a negative 2, I get negative 2 minus 2 is negative 4. So that works. Okay. Next one, same thing. I can multiply both sides by x plus 10. X plus 10. Cancels. Cancels. I get x squared equals 100. Take the square root of both sides. I get x equals plus or minus 10. So my two solutions here are x equals 10 and x equals negative 10. But if I look back, I have x plus 10 in the denominator, right? X plus 10. So I don't want x plus 10 to equal 0. So if I substitute in a negative 10, negative 10 plus 10, that's going to give me my 0, right? So I can't have a negative 10 in the denominator. it has to be x equals positive 10. Because I can't get a 0 in the denominator. If I plug in negative 10 or substitute in negative 10, it's going to give me a 0 in the denominator. So it doesn't work. It's extraneous. Right? These are extraneous. Right? This one doesn't work because it's extraneous. It's extraneous. Extraneous. Okay. All right, let's look at the next set of problems. Okay, we need a common denominator. So my common denominator here is going to be all the unique terms in the bottom. So I have x plus 3, but I also have 2x minus 1. I have x plus 3, and I have 2x minus 1. Okay, in the first term on the left side of the equal sign here, I have an x plus 3, but I'm missing a 2x minus 1, so I need to multiply the bottom by 2x minus 1. If I multiply the bottom by 2x minus 1, I need to multiply the top as well. Okay, I distribute my 3. That's going to be 6x minus 3. On this side, I'm missing the x plus 3, right? So I need to multiply the bottom by x plus 3 to get the denominator I want. But if I multiply the bottom by x plus 3, I need to multiply the top as well. So I get 4x plus 12. Okay, since our denominators are the same, right? If I were to multiply both sides by x plus 3 times 2x minus 1 on this side, and then I have to multiply the other side. Right, my denominators are going to cancel, and I'm left with 6x minus 3 equals 4x plus 12. From there, I just have to do a little bit of algebra to solve. So I need to subtract 4x from both sides. Add 3 to both sides. So plus 3, plus 3. I get 2x equals 15. And when I divide both sides by 2, I get 15 over 2, which is 7.5. Okay, 7.5. All right, the next one, common denominator. So I have an x minus 2 and an x plus 4, so I need to include both of them. So x minus 2 times x plus 4. X minus 2. X plus 4. Hand's getting a little cramped here, writing. So I have x minus 2. I'm missing the x plus 4 on this side, so I need to multiply by x plus 4 on the bottom to get the denominator that I want. And if I multiply it on the bottom, I got to multiply it on the top. I distribute, I get 4x plus 16. Okay, on the other side, I have x plus 4, so I'm missing the x minus 2. So I got to multiply the bottom by x minus 2. I have to also multiply the top. So I get x squared minus 2x over here. All right, I can multiply both sides by x minus 2, x plus 4. And if I multiply the left side, I have to multiply the right side by it as well. So my denominators are going to cancel. And I'm left with 4x plus 16 equals x squared minus 2x. I'm going to subtract 4x from both sides. I'm also going to subtract 16 from both sides. So I get 0 equals x squared minus 6x minus 16. So this time we have a quadratic. To solve a quadratic, we need to use the x method. So I need to find two numbers that multiply to negative 16 and add to negative 6. That's going to be negative 8 and positive 2. So my factors here are going to be x minus 8 and x plus 2, which means my solutions are x equals 8 and x equals -2. Okay, if I check, I can't have a +2 or a -4. So the -2 is good, right? Because the x value I can't have on this one is a +2. That would give me a 0 in the denominator, but -2 is good. Okay. -2 is just fine. All right, last two, 8 and 9 here at the bottom. Ooh, not gonna have a lot of room. Let me see if I can zoom in on the page. Scroll down. All right, we'll just do one at a time here. Okay, the first one, we got to factor our denominator. So I have 1 over x plus 3 plus 1 over x minus 3 equals, this is the difference of two squares. So it's going to factor to x minus 3, x plus 3. Right? So our common denominator here then, once we factored the bottom, is x minus 3, x plus 3, x minus 3, x plus 3, x minus 3, x plus 3. Okay. The first term here has an x plus 3 in the bottom, but it's missing the x minus 3, so we need to multiply by x minus 3 on the bottom. If we multiply the bottom by x minus 3, we need to multiply the top as well. You distribute your 1, that's just 1 times x is x, 1 times -3 is -3. Okay, this one has an x minus 3, so what we're missing here is an x plus 3. If you multiply the bottom by x plus 3, you got to also multiply the top. Distribute your 1, simply gives you x plus 3. All right, and then this side, your denominator is already set, so we're just going to bring down the 6. Okay, my denominators are all the same, so I can multiply everything by x minus 3, x plus 3, and those all cancel. Right, so all my denominators are going to cancel, and I get x minus 3. I can just combine these right here, right? So x plus x is 2x. -3 plus 3 is 0. And then equals 6. Divide by 2. I get x equals 3. Okay, the problem with this, right, is x cannot equal 3. And x cannot equal -3. So since x cannot equal 3, it's extraneous. Extraneous. Okay, so there is no solution, right? No solution to this problem. Okay, no solution at all. There's no value of x where this will work. Where it's true, right? There's no value of x that makes this statement true. Okay, let's go over here and try number 9. Okay, first thing we want to do here is we want to factor the denominator. We have a quadratic, so we need two numbers that multiply to -24 and add to 2. That looks like it's +6 and -4. So I have 2 over x minus 4 minus 3 over x plus 6 equals 4 over x plus 6, x minus 4. Okay, so all the terms I see are x plus 6, x minus 4. That's going to be my common denominator. X plus 6, x minus 4, x plus 6, x minus 4 equals, and then x plus 6, x minus 4. Okay, So on the first one, we're missing an x plus 6, so I need to multiply by x plus 6. So that's going to give me 2x plus 12. Okay, over here we have x plus 6. So we're missing the x minus 4. So we got to multiply by x minus 4. That's going to give me 3x minus 12. Okay, and then this one's good, so it's just going to be a 4. All right, I can multiply everything through by x plus 6, x minus 4, so my denominators all cancel. I got to distribute my negative. So 2x minus 3x is negative x. 12 plus 12 is going to be plus 24. And then it's going to equal 4. I'm going to subtract 24 from both sides. So I get negative x equals negative 20. And then when I divide by negative 1, I get x equals positive 20. Okay, and that's it for 5.